Please confirm.
What is he doing?
He's beginning to believe.
They're trashing our rights, man! They're trashing the fluid data! Hide the planet! Hide the planet!
Shut up and get in the car!
Hide the planet!
So one of the tricky aspects of game development is learning how to program. It can be tricky to understand what you're actually doing and how these skills kind of apply to game development, especially with the C# programming language and the Unity game engine. So for this video, what we're going to do is we're going to look at programming in general to figure out what it is, what the C# programming is, and how it does things a little differently. And then we're going to go through a practical example of how we can use these skills in order to add features to our game. So what is programming? Basically, it's just the idea of giving instructions to a computer so they can do stuff for you. Computers operate through binary logic, so just ones and zeros, and so it's very literal in everything that it does. And it can be used to represent different sorts of types of data too, like words or numbers or the color red, or even to output an entire video game that you can enjoy. So originally they actually did use binary logic. They used like little punch cards to operate as the ones and zeros or on and off switches. But that was kind of a pain in the butt, so they came up with the idea of a programming language. So a programming language is a bit more human readable. It uses keywords and statements and basically just gives you a set of instructions for the computer. So it goes through a middle manager, usually a compiler or an interpreter, which will then convert your human readable source code into machine readable machine code, which the computer can then go and run off with and do its thing. Roughly speaking, every programming language does the little compilation process a little differently, depending on what it was designed for, but roughly speaking, that's basically all we're doing here. Now technically the compiler is also a machine, but it's just one that's kind of designed specifically to deal with people, but the source code still needs to be pretty precise, or there needs to be attention to detail, so you might find yourself making a lot of spelling mistakes, or there's a bracket out of place, or there's a semicolon that's missing or something like that. That will actually, cause the computer to, implode in on itself. Not literally, but it just won't work. So the compiler is just there to be your friend and say, hey, maybe you should fix all this stuff before I pass this on to the machine, so you don't end up accidentally shooting yourself in the foot. There's different sorts of programming languages depending on what purpose you want to code for. Over time, there have been different innovations in the field of programming and computer science in general. So that's why they came up with the idea of object-oriented programming, which we will explore in the next section. We're using the C# programming language, which kind of forces the user to use the object-oriented programming style. And so broadly speaking, the idea is that it organizes everything into classes. So a class just bundles data with the logic that uses the data. So if you think of a bank machine, the data would be the account balance, whereas the logic that uses the data would be like a method for withdrawals or deposits or checking the balance. What we're using it for is specifically in regards to game development, which you can think of it more like creating your own custom components. Now the Unity game engine comes with its own components, and they did all the coding for that, but generally speaking, you want to do more complex interactions between these components, and they don't have a component for every situation because you can kind of code that yourself. So enough theory, let's go ahead and just give you a practical example so you can see how you're going to use these skills in the actual game engine itself to add features and solve problems. Okay, so let's have some fun here. So I'm going to show you a little prototype of a game. We're going to encounter a problem, and then we're going to use coding to actually solve that problem. So this is going to look a little rough, but just bear with me for a second. This is a little shooting game, so you can see, actually let me make that a little bigger. So we got a little green dude in the front there. He's got his little guns here. And so you can see from the white square and the little cylinder that's floating around, it's following my mouse right now. That I can move it around and I can start shooting, and it creates a little puff of dust wherever I try to shoot my little guns. So this little red ball up here is representing our enemy, so if I run up to it, I can start shooting it and nothing really happens, right? So it wouldn't be great if, I could actually destroy that game object or delete it somehow. But let's say, I'm new to game development, I don't know how to do that. The solution would be, and what's missing from most tutorials is, I could give you straight up the answer, but what you'd actually do is find something like use your internet browser, and you'd type into Google. Usually preface it by saying Unity, just because it's a keyword, so right away Google will know what you're talking about, and you just do your best to try to explain what the problem is. So Unity, how do I kill game objects? And so in this case, it's the first result, destroying a game object. So if I click on that, obviously there's going to be a little reading involved, and you might have to read through a couple pages in order to get the solution you want. But over here, it just gives you a bunch of information, but we can go right to the first line here, and it gives me the syntax, or the way of explaining how you actually destroy a game object. So it's destroy, bracket, game object, And apparently you can put in a time delay too, which is neat, but not going to be necessary in our case. So right here, this is the line we really want right here. So this is how we destroy a game object. And so it's just going to remove it from the game, so it's like it got destroyed. So now we just got to think of how we want to incorporate that. So we know we're going to need a script in that after a period of time, once it gets shot a couple times, it'll destroy the game object. So we right click, say create a new C# script. I'm going to call mine, you can call yours whatever you want. Naming structure doesn't super matter, but I think you can't start with numbers or symbols or anything like that. So we're going to say monster health is what we'll call it. And it's going to give me a bunch of old code, because it's kind of buggy when it does this thing. I think what it wants to do is it wants to automatically open up your script, but it never does it on the first go around. So there we go. So right here you can see, let me just scroll in a bit here. There's a lot of boilerplate code on here, which doesn't super matter. Like this stuff up here, using statements. All you really need is the Unity game engine one, and that gives you the source code for how to turn the script into a component. So already right off the bat, there's been a bunch of coding done for us in order to get the features that we want. And so that's what it's trying to advertise here. So we've got public, which just means anyone can see it. Woohoo. The class, which we already talked about, and then you can recognize the name right here, monster health, which inherits from the mono behavior class. So there's another class with a bunch of code that's defining certain functions and how to be utilized like a component. And so it gives you some boilerplate code, which we'll use, but we don't actually need right now. I just want to illustrate that this is all the code you actually really need. So right here in between these two brackets is where all the magic really happens. So, when we're talking about classes before, we talked about bundling data. So the data we need here is we want to have an HP value, right? So you may not understand all this right off the bat, but we're giving them 100 points of health. So there's our data. And then we want a function to actually make him die, right? So, or rather, just to take damage. And then in that take damage method, we'll figure out, when is he dead. So public void take damage, and we'll take in an argument for int amount. Whoops. Well, bam. So we want to remove the amount from the HP minus equals amount. If HP is less than 0, or equal to 0 actually, we will go ahead and use that code we looked up earlier to destroy the game object. And the IntelliSense is already giving us the automatic. It knows what we're up to. And that's that. So the other part to this is, when does this take damage actually get called? Like it's not going to operate on its own. It needs to, kind of needs to be prompted first. Okay, so I just jumped into my shoot script. So I have another class that determines how the player shoots stuff around the world. And so this isn't really meant to be a coding tutorial, so I'm just skipping ahead just to show you exactly where I would incorporate this take damage function or method that we just invented. So we go to a shoot component, and there's a raycast. Again, this is all stuff you'll learn down the road when you're doing game development. But basically a raycast is just making a line from point A to point B. So what these lines just did is, did the line actually hit something? And if it did hit something, try to access its monster health component. But and if it doesn't have a monster health component, that's what this checks for. So this is going to make sure that it actually has a monster health, because if you try to call a method on a component that doesn't exist, then everything's going to fall to pieces, right? It doesn't know what you're talking about. So we go to the monster health and we say monster health dot take damage, and we'll just we'll give it 20 points. The other thing I'm going to do here is I put a little fancy blood effect. So every time you shoot something, it just gives you, because it's all going to be happening in the background, like 20 points is going to come off the 100 hit points of health, but there's no way to display that at the moment because we're still early in development. So I'm using a little special effect of that. So any script that you use, you can use. And we just add it just like that. So we get back to here and we make it bigger again, and we can now start shooting again. And we run it to our ball, and this time when we shoot it, 2, 3, 4, 5, 20 times 5 is 100, had 100 points of health, now it's dead. So huzzah, I have a way of shooting enemies now, and that's kind of how that works. So a fair question to have right now is, what the hell just happened? What I was trying to illustrate in the previous section was just the process of coming across a problem, researching a solution, and then incorporating it into your source code. I typically, when I was starting out, I typically wouldn't write anything from scratch. Think of it like building up your toolbox. So right now your toolbox is empty, you don't know how to do anything. So you go online, you go through a C# tutorial in order to learn some of the basic fundamentals. And then what I would do is go look up a tutorial for a game that's similar to the one you want to make. If you want to make like a first-person shooter or like a Mario game or something like that, like a platformer, then at least you can follow along and you have some baseline knowledge. Like maybe you don't like how the tutorial creator did things, right? You want to mess around with the settings. Like it's a lot easier to tweak pre-existing code than it is to write everything from scratch. So that's where I'd probably do the starting base. If you do want to do everything from scratch, then I try to keep your game project as small as possible. So think chronologically, like the earliest games, like arcade games. Back in the day, it was a lot more complicated because they had to do everything, not quite machine code, but probably pretty close. Whereas now we have the technology, we can make state-of-the-art 3D graphics. So making Pac-Man or a Mario code probably wouldn't be too bad right now, but obviously getting that movement scripts and learning how to program, it's enough on its own, right? But once you have that baseline knowledge, so you have those scripts for your first game, you can kind of build off that knowledge for future successive tests. So yeah, maybe you didn't get everything you wanted in that first game, you wanted a rocket launcher or a jetpack or something like that. So you just take that out, focus on the simple stuff, get your game done. Then for the sequel or for a completely different game that's in the same genre, you can add in those different features. And the reason is because there's a lot of research involved in game development, so you have to constantly look up solutions to every single problem, so you can kind of get decision fatigue, and so that's why they always encourage you to keep things tiny. Like one room, or don't do a full-featured game on your first thing, but do things that are similar to the projects that you want to do. Right? You still want to make an exciting game and something that's fun that you can show off to your friends and family. And so this particular video was very focused on coding. There's probably still other questions you have, like what about artwork? How do you get 3D models, to make your game look pretty? Or how do you get music? How do you generate your own music? Those are all good questions to ask and would probably be great ideas for future videos. But I'm going to leave it here for now, so I will see you next time.
Hide the planet! Hide the planet!
Shut up and get in the car!